There's a really quick review of the 5 types of chemical reactions. So there's some characteristics that we're kind of looking for, some clues to differentiate these reactions. And I want to start with what to me is sort of the most obvious one, which is combustion. You absolutely must have carbon dioxide and water as products. I would highly recommend taking a peek at the PowerPoint for this because this is really self-explanatory. It's just nice to get a couple good examples down. But take a look at the rules and the definitions for each one. But for combustion, you must have carbon dioxide and water, and then it's just going to be in varying amounts. So for combustion, no. Here we go. So here we go for combustion. The other part of the definition is that oxygen must be one of the reactants. So you have a carbon-based particle reacting with water, or with oxygen gas, sorry, to form carbon dioxide and water as products. I think the other one that jumps out at most people is decomposition, where you start with one substance, and the chemical reaction creates 2 products. So if we go through and we just look where our arrow is, here we go. So we could see that the zinc chloride, zinc chloride decomposes to form zinc and chlorine gas, probably. But we only have just the single reactant there. For synthesis, it will be the flip. So we'll have 2 reactants, but there should only be 1 product. So let's go through. Let's go more than 1. Here we've got 1. Even though there's 2 particles there isn't like a different kind of compound here. So there's just 1 single compound at the end. So iron reacts with oxygen to form iron 3 oxide. Isn't that interesting? That's iron 3 oxide. But we'll that's for another video. So synthesis. So two compounds coming together to form 1 single product. So what's left then is single replacement and double replacement. And this strategy of just kind of eliminating reactions, that's sort of a legitimate strategy. So with a single replacement, we have 1 single compound just kind of sneaking in and scooching out one of the other elements in a compound. So it's not a double replacement where they're switching spots entirely, where the 2 compounds switch their ingredients. This is just one kind of sneaking in and kicking another out. So in our last reaction here, we can see hydrogen is going to kind of cut in. And if you think about the PowerPoint, they show the dancers. So this is like somebody cutting in and kicking the other one out. So hydrogen comes in, iron gets kicked out, and you can verify that by looking at the product. So we see iron all by itself at the end, whereas hydrogen has gone in its place. So this is single replacement. And some people, they know this as displacement, but double displacement or replacement, but I think it's okay to stick with replacement. And so then that leaves our top equation here. You'll notice that also, like, positively charged particles will swap with other positively charged particles, and the negatively charged particle will swap with its negatively charged counterpart. So here we've got calcium, which is a 2+, and hydrogen, which is a plus. So let's switch those guys. And so they can entirely switch spots. And, you wouldn't say that the other guys are also switching, because then they would be just back to where they started from. But calcium and hydrogen swap spots, so calcium's with the nitrate and hydrogen's with the hydroxide. Or you can consider it the anions being switched, but that should be considered double displacement, double replacement.